Now we have discussed the subject design of machine movement. Topic is shaft coupling. So prepared by Jabbar Singh, Assistant Professor, Department of Mechanical Engineering. Now introduction. The shaft are usually allowable up to 7 meters length due to the inconvenience in transport. In order to have a great length, it is become the necessary to join two or more pieces of the shaft by meaning of coupling. Shaft couplings are used in the machinery for the several purpose. That most common of the which are following. First one, the provided for the connection the shaft unit that are the manufactured separately, such as the motor and generator, and to provided for the disconnection for the repair for alternatives. This same point to provide the misalignments of the shaft or the introduce mechanical flexibility. That point to reduce the transmission of the shaft load from the one shaft to another. To introduce the protection against the overload, it should have no projecting parts. Next, the requirement of the hood shaft coupling. A hood shaft coupling should be have following requirement. It should be easily to connect or disconnect. It should be transmit the full power from one shaft to other shaft without loss. It should be hold the shaft in perfect alignment. It should be reduce the transmissions of. So next, types of coupling. The shaft coupling are divided into two main groups of follows. First one, rigid coupling. It is used for connect the two shafts which are the perfectly aligned. Following types of rigid couplings, the importance. So first one, the sleeve or muff coupling. So that is the diagrams are there, different arrangements. The axial misalignment, radial misalignment, and angular misalignment. The next, clamp or split muff or compression coupling. Third one, the flange coupling. So flexible coupling, it is used to connect two shafts having the both lateral and angular misalignment. Following types of flexible couplings are important from the subjected point of view. First, fused pin type coupling, universal coupling, old arm coupling. Next, sleeve or muff coupling. It is the simplest type of the rigid coupling they made for the cast iron. It consists of hollow cylindrical hose inner diameter of the same of the shaft. It is the fitted over the end of the two shaft by means of Gibbs keys. The power is transmitted one shaft to another other shaft by means of the key and sleeve. Usually the promotions of cast iron sleeve couplings are follows. The outer diameter is the sleeve D is capital D is equal to 2 into D plus 13 mm, and length of the sleeve L is equal to 3.5 D. Where D is the diameter of the shaft, the design sleeve muff or muff couplings, the following procedure may be adopted. Then that is the simplest problem for the coupling, muff coupling. So the problem is the design and make of the neat dimensions of sketch a muff coupling which is used to connect two steel shaft transmitted 40 kN at 350 rpm. The material for the shaft and key is plain carbon steel for the which allowable shear stress, crushing stress may be taken as 40 megapascal and 80 megapascal respectively. The material for the muff is cast iron for the which allowable shear stress may be assumed as the 15 megapascal. So the given data, first of all, what are the data are available? The load P is equal to 40 kilonewton. We have converted to watt, 40 into 10 power 3 watt. The RPM 350 RPM, and shear stress 40 megapascal, that is also converted to Newton per millimeter square. Then again stress, crushing stress, that is 80 megapascal, that is also converted to Newton per millimeter square. Then crushing shear stress, that is also we have converted to Newton per millimeter square, 15 Newton per millimeter square. To find the muff coupling designed. So we have find the muff coupling design. So first of all, design for the shaft. So first D, so diameter of the shaft. We know that the torque T is equal to P into D divided by 2 pi n. So all the data are there. We have applied it in this formula. We got the answer of 1100 into 10 power 3 Newton meter. We also that the torque transmitted T is equal to 1100 into 10 power 3 equal to pi by 16 thou x into dq. So that is the one type of the formula, torque transmitted formula. We have applied that values or given values and calculated values in this formula. We got the diameter d is equal to 52. So we have round value is 55 mm. Then next we have discussed the design of sleeve. So that we know that the outer diameter of the muff is equal to capital D is equal to 2d into 13 mm. So that we know the values of given data. So we applied in this formula, we got the answer of capital D is equal to 123. So we have the round of value is 125 mm. The length of the muff is equal to 3.5 into D. So we can multiply 3.5 into 55 is equal to 92.5. So the round value is 195 mm. So we can apply the formula of hollow shaft. So torque formula. So we can apply the formula of torque and hollow shaft. Then we apply the value 1110 power 3 by 16 out the capital D is 4 minus small d raised to 4 divided by d. So we got the crushing stress sigma is equal to 2.97 Newton per millimeter square. So since the introduced the shear stress of muff, that is cast iron, is less than the proximal shear stress, that is 15 Newton per millimeter square. So the design of muff is safe. Next, design of key. So from the table we find out the shaft 55 mm diameter, the key W is equal to 18 mm. Since the crushing stress, the material twice the shearing stress. Therefore, the square of key may be used in the thickness of key. T is equal to W is equal to 18 mm. We know that the length of the key is each of shaft. So L divided by 2, that is 97.5 mm. So here we know that the torque transmitted T is equal to, we apply the torque formula, we got this stress tau S equal to 22.8 Newton per millimeter square. Again we know that the torque transmitted, we have calculated the sigma CS, that is also 45.6 Newton per millimeter square. Since the introduced the shears and crushing stress are less than the permissible stress, so therefore the design of key is safe. Thank you.